So in this session, we'll start Unit 2, which is about the waves and electricity. So first part, we'll discuss about the waves, the types of the wave, the nature of the wave, the properties of the wave. And the second part, we will discuss about the electricity, the circuits, the DC circuits. So starting with the first topic, these are the learning objectives of the session. First, how we define a term wave, or what is the definition of a wave? Wave is simply a mode of energy transfer. Like if you want to transfer energy from one place to another, using the wave, we can also transfer the energy. So basically what happened, like example, if this is a water surface and there is an object which you move up and down or vibrate up and down. So the water surface is there and you're moving the object up and down or vibrating up and down. What it causes, it produces a disturbance. And what happens, this disturbance transfer from one place to another in the form of wave. So if any boat is there or any object is there, that also tend to vibrate or vibration occur for the object which is at the other end. So basically what happened, wave is a mode or a way of energy transfer. Using the wave, we can transfer the energy from one place to another. But when the energy transfer is there, the matter does not transfer. What does it mean? The matter does not transfer. Like example, these green spots are representing the particles. So if these spots, the green spots are representing the particles. So as the vibration is produced or the disturbance is produced, this causes the particle to move as well. So some of the particle will move up and some particle will move down. So as these particle will move or vibrate, the particle won't move from one place to another. The particle will remain at their the specific position. They will only vibrate up and down or right and left. So particle not travel from one place to another, but the energy actually travel from one place to another. So the disturbance that move itself an energy, but not the matter. Like the matter or the particle does not travel from one place to another, and they required a medium to transfer energy through, and the particles in the medium do not move with the energy, they just oscillate from its mean position. And the particle, there are two ways the particle can oscillate. The particle can oscillate up and down, or the particle can oscillate right and left. There are two ways the vibration of the particle can occur. If the particles are moving up and down and the wave is traveling towards either right or left, so they are 90 degrees to each other or perpendicular, so what we call this wave, we call that as transverse. But if the wave, the particles are vibrating parallel to the direction of the wave, so this is the direction in which the wave is traveling, and the particles are moving same as or vibrating as same as the direction of the wave. So what we call that wave is known as longitudinal. So wave can be transverse wave or it can be a longitudinal wave. So as you can see, the types of the wave. So wave may be mechanical. Mechanical wave means it requires a medium like sound waves. They need particles to travel. And wave can be electromagnetic. Electromagnetic means a wave without a medium can travel. And then it can be further classified into transverse and longitudinal. So what is the concept of a transverse wave? The transverse wave in the particles are vibrating perpendicular or 90 degrees. As you can see here, the particles are moving up and down and the wave is traveling either right or left. And the second one, the particles are moving right and left, and the wave is also moving either towards right or left. So direction of the particle is same as the direction in which the energy transfer. Is it clear till this point, the concept? So in a transverse wave, the particles vibrate perpendicular to the direction of the wave, as you can see here in this animated image, that the water particles are there. These are the water particles or particles of the water. So these particles are moving up and down. But what happened? The wave is traveling towards the right hand side. So when you compare the direction of the particle and the direction of the wave, so direction of the particle is up and down and the direction of the wave is towards the right hand side. So we call that as transverse wave. Another example of a transverse wave, which is just to compare the speed, as you can see, as the particles are vibrating up and down, they're transferring the energy. If the particles are vibrating faster, then the rate at which they transfer the energy will be greater. If the particles are vibrating slower, then the rate at which they're transferring the energy will be smaller. And some examples of the transverse wave: radio waves, microwaves, infrared, visible, ultralight, ultraviolet, X-ray, and gamma. These all are transverse waves. And for a transverse wave, we define the term amplitude. What is the concept of amplitude? Basically, the highest point of the wave is known as the crest, and the lowest point of the wave is known as trough. So the distance, the height of the wave or the depth of the wave, like distance from mean position to the extreme position, either for a distance from mean position to crest or mean position to trough, that distance is known as amplitude. Whereas the distance between the two successive crests, like when we work out the distance between the two consecutive or successive crests, like from one crest to another, that's known as wavelength and denoted by a Greek alphabet lambda. Same way, distance between the two successive trough is also known as wavelength. From one trough to another, this distance is also known as wavelength. Or there's also another way, length of one wave. The length of one wave is also known as wavelength. Like example, if this is a starting point of the wave, this is the ending point of the wave. So from start to end, the length of the one wave is also refers to a wavelength. So whenever you have a transverse wave, you should be able to label wavelength and amplitude. So in this question, use the chat to state the answer. Which point is exactly wavelength apart from A? So from A, which point is wavelength apart? Like one complete wavelength. Is it B, C, D, E, F or G? One complete wavelength. So the answer is E. E is actually one complete wavelength apart. When you check E, this is one complete wavelength, because what happened? Like here we started the wave and then we completed. Then again from same point a new wave started. That's why E is the right answer for this. Okay, another example, transverse wave. We have to work out which are wavelength apart. For D, which point is wavelength apart? You can use the chat to state the answer, and I want participation from everyone. Which point is wavelength apart from D? So when we work out, like we should read the same point. So this is D, and D matches with what? It matches with P. So actually point P is wavelength apart from D. Now J. Point J is there. Which point is wavelength apart from J? Yeah, that's right. So wavelength apart from J, when we take, this will be, V will be the wavelength apart from J. Then for B, which point is wavelength apart from B? This is point B. So which point is wavelength apart? One complete wavelength. So when we complete, it matches with N. So the correct answer here is N. Then for M, which point is one complete wavelength apart? Yeah, that's right. When we work out from M, because from M to A, this is one complete wavelength apart. And for L, the last one, which point is one complete wavelength apart from L? Yeah, that's right. So for L, the one complete wavelength apart, that is X. Because this is why T is not the right answer. Why X is because T is just a halfway point. When the new wave, like example, because new wave start from here, so new, the same position new wave started, so that's why from starting to the ending position of the first wave we call that as wavelength apart. So the correct answer for the last one, L, is X. Is it clear? This exercise in which we work out the points which are wavelength apart. Then number of waves per second. What is the concept of the frequency? Frequencies refers to how many waves are there, how many number of waves per second which are passing through a point, and the symbol is F and the unit is hertz or second inverse. Example, if you focus on one of the point with a 10-second timer, example, focus on this point and tell how many vibration in 10 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vibration. So it is having 10 vibration in 10 seconds. So it undergo 10 vibration in 10 seconds. Frequency means how many vibration in 1 second. So in 1 second, how many vibration will be there? X. When we cross multiply, so X will be equal to 10 divided by 10. So X is equals to 1 hertz. So the frequency here is equal to 1 hertz. The next example, focus on this. How many vibration are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 vibrations. So if you want to work out the frequency, there are 14 vibrations in 1 second, in 10-second timer. So in 1 second, how many vibrations are there? X, when we multiply, it will be 14 divided by 10. The total number of vibration divided by time interval, so it will be 1.4. And the last example, if you focus on any one of the point, you can take, it's not necessary you take the peak, you can take any one of the point. The peak points are easy to identify, recognize. That's why I'm taking those. So when you check, it is 1, 2, 3, 4, 5. So there are 5 vibration in 10 seconds. So if it is having 5 vibration in 10 seconds, say in 1 second it will be x, so 5 divided by 10. So how many, what will be the frequency? It will be 0.5 hertz. So the frequency will be 0.5 hertz. So the one which is having a higher frequency will undergo greater number of vibration per second, and the one which is having a lower frequency will have least number of vibration or small number of vibration every second. So frequency of the wave is refers to number of the vibration every second. Then what is the period of the wave? Period of the wave means time to complete one vibration. As you can see here, the first one, the frequency for the first one, when we it is 1 hertz, or it undergo 10 vibration. The first example, it was 10 vibration in 10 seconds. So the for one vibration, for each vibration, how much time it took, x, so cross multiply. So the time period will be 1 second, and time period is denoted by normally capital T, so time period is 1 second. What about the second one? It undergo 14 vibrations in 10 second. So in one vibration will be there in x second. Cross multiply. So number of the vibration every second. So it will be the total time divided by number of vibrations. So it will be 10 divided by 14. So 10 divided by 14. That is 0.71. So time period here is 0.71. And what about the last one? It was having 5 vibrations in 10 seconds. So one vibration will take x. So when we cross multiply, what will be x? It will be 10 divided by 5, which is equals to 2 seconds. So like each vibration is approximately taking 2 seconds. So when we compare, the one which will have the highest frequency will have the shortest time period, and the one which is having the lowest frequency will have the longest time period, because frequency refers to number of vibration. If greater number of vibration every second, then the time for each vibration will be. So if frequency increases, the time period will decrease. Is it clear? Any doubt till this point? Then the period, as we discussed, so we can take a reciprocal of the frequency, we'll get the time period. And the wave equation, the formula which relate the speed of the wave with the frequency, that is speed is equals to frequency times wavelength, or v is equals to f lambda. And this formula is valid for all kind of waves. It does not depends on the nature of the wave. Even it's a transverse wave or a longitudinal wave, we can use this formula. to calculate the speed. So example, this is a wave equation triangle. If we need v, that is equals to f lambda. But if we need f, that is v divided by lambda. And if we need lambda, that is v divided by f. So all the three variable can be found by using this triangle. So this is an example question. The diagram shows how the displacement of a water wave vary with the time. The wavelength of the water wave is 8 centimeter and the time interval is also given. State the amplitude. So what is the amplitude here? What is the amplitude of this water wave? So amplitude or the height of the wave, that is 2 millimeter. Height or the depth. Then calculate the frequency. Frequency means number of vibration every second. So how many vibrations are there? 1 vibration, 2 vibration and 2.5 vibration. Even if we know the time period, frequency is reciprocal of the time period, or frequency is number of vibration divided by time. The total vibration divided by total time. So we can use any of the formula. The time period here is 0.5 because that's a one complete vibration. So frequency will be 1 divided by half, that is equals to 2 hertz. So frequency of this wave is 2 hertz. And then calculate the wave speed. We have the formula v is equals to f lambda. Because the wavelength is given in centimeter, as the wavelength is given in centimeter, our final answer is centimeter per second. If the wavelength was in meter, then our final answer will be meter per second. Then another example, a radio station broadcast on the wavelength of 250 meters. The speed of the radio wave is 3 exponent 8. Calculate the frequency. How to calculate the frequency? We have the formula v is equals to f lambda. So f is v divided by lambda. V is the speed, which is 3 exponent 8, and the lambda is the wavelength, which is 250. When we divide, it will be 1.2 into 10 to the power 6 hertz, or 1.2 megahertz, or 1200 kilohertz. Then what is a longitudinal wave? A longitudinal wave in which the particles are vibrating parallel to the direction of the wave. As you can see here, like this is a sound wave. So how the particles are moving? They are moving right and left, and how the energy, which direction energy is transferred? The energy is also transferred from left to right. So direction of the particle and the direction of energy transfer is same. So what we call this wave, we call that as longitudinal wave. And in a longitudinal wave, there are regions where the particles are very close to each other. The region where the particles are closer to each other, we call those as compressions. And the region where the particles are away from each other, we call that as rarefaction. So whenever you have a longitudinal wave, there will always be a region of compression and rarefactions. So in this previous picture, as you can see, basically what happened, the wave is transferring in all the direction. It is moving towards right, it is moving towards left, in all the direction. So when we compare the movement of the particle, the direction of vibration of the particles, so how the particles are moving as same as the direction of energy transfer, that's why This is also known as longitudinal wave, because if it was a transverse wave, then the particle should move perpendicular or 90-degree to the direction of the energy transfer. So the region of a high pressure are compression and region of low pressure are rarefactions. Is it clear, the concept of the two types of waves, longitudinal and transverse? Then what is a progressive wave? Progressive wave is a one in which the wavefront or energy transfer continuously. So there are two types of wave. One is called a progressive wave, another one is stationary or a standing wave. What, like example, you are at position A and you're calling your friend at position B. So when you produce a sound, your energy, your wave will actually travel from one place to another and it will reach your friend. So this type of wave in which actually the wave travels from one place to another or continuously changes the position, we call this as progressive wave. But what is a standing wave or a stationary wave? Example, we have a string or a wire. So there's a wire or a string which is fixed between the 2 points. And you disturb, like example, you take a rubber band in your hand, like stretch the rubber band between the fingers. And then if you disturb from the center, when you disturb this rubber band from the center, as a result, what you will see? You will see it will produce a pattern in this manner. So when it will produce a pattern in this manner, and actually what happened, this wave is confined in the region. Like this wave is produced within the region, and this wave cannot travel from this point to any other point. So if the wave is not, if wave is confined in the region, wave is trapped in the region, that kind of wave is known as standing wave. So first one was a progressive wave in which actually the wave can move from one place to another, and the second one is a stationary or standing wave. What happened in a stationary or standing wave, that the wave cannot actually travel from one place to another, it is confined or it is constrained in a region. Is it clear? First, the concept of standing and progressive wave, how it is formed, how standing wave is formed, that we will discuss in detail later in this topic. So I'm not going in detail how it is formed. The first point is you should understand the difference between the standing and the longitudinal wave. So this is a comparison. You should be able to compare these two types of waves. A stationary wave store vibrational energy, progressive wave transmit. Like example, how what does it mean? So in a stationary wave, what happened? So wave is confined in the region, wave is trapped in the region. So when the wave is trapped in the region, it cannot go from this region to another. So it stored the vibrational energy, or vibration energy stay there. But in a progressive wave, from the source, actually the energy travel from one place to another. For stationary wave, the amplitude varies. Like you can see at the center, it is having a maximum amplitude, but near the end, it is having the minimum amplitude. But for progressive wave, amplitude is constant, because amplitude means the maximum displacement from mean position. So here, the maximum displacement from mean position, all the points will be same. And the region where the amplitude is minimum, that region is known as a node, and the region where the amplitude is maximum, that is called antinode. So all the points between any two adjacent nodes or antinodes are in phase. What is the meaning of this term? That all the points between any of the two adjacent nodes are in phase. Like example, so if we have a rubber band and we stretch this rubber band between the 2 points and disturb, so when we disturb, the rubber band will vibrate. This is how it will appear. So what happened? What does it mean? All the point between the two adjacent nodes. What is the node? Node means the region where the amplitude is 0. That is called node. And this is also a node. So they're saying if we take any particle, like if we say this part of the wave, so the particles which are moving in this part of the wave, they all are in phase. What is the meaning of in phase? Means they all are moving in the same direction. Or if we take the particles at the top, so which direction they tend to move? They tend to move downward. So all the points, they have the same way of vibration. So when all the points have the same way of vibration, we call that they all are in phase. But for a progressive wave, the phase varies smoothly with the distance. What does it mean? Like example, if this is a progressive wave, progressive or wave is traveling, so how the particle will tend to move? Like in this region, the particle tend to move down, but here this region, the particle tend to move up towards the mean position. So as these particles are, they have different way of vibration. Like particle A and particle B are not vibrating in the same manner. Particle A is moving down where particle B is trying to move up. So the way of vibration of two particles in the wave is opposite. Why here we did not say? Because what is the possibility? Either the particles will be at this point, all the particles will be here at the lower point, or all the particles will be there at the higher point. So if we consider all the lower particles, they are moving in same way. Because in a standing wave, the position of the wave, either it will be at the bottom or it will be at the top. But in a progressive wave, some of the particles are moving down and some of the particles are moving up. So it means the phase of the wave is continuously changing. Is it clear? Then the distance between the two successive nodes is lambda by 2 for a standing wave. Like when we have a standing wave, so this is a standing wave and this one is a progressive wave. So region where the amplitude is minimum, that's node, and where the amplitude is maximum, that is antinode. So the distance between the two successive nodes, when two nodes are there, the distance in terms of wavelength is half of wavelength. How it is half of wavelength? Look, when I complete, this is one wave. So when you produce it back, so it will appear like this. Now here we have node, node, and node. So three successive nodes, that is one complete wavelength. Like distance from one node to another and to the third one, that is a one complete wavelength, or lambda. But what is the distance between two successive nodes? When two nodes are there, what will be the distance between them? That will be equal to lambda by 2, or we also say half of wavelength. But here in a progressive wave, there is no antinode or node. The distance between, either if there are crests, then distance between the two crests will be lambda, or distance between the two troughs will be lambda, or one complete wavelength, that will be lambda. But in standing wave, the distance between the two successive nodes, that is equals to lambda by 2. And the distance between node and antinode, the quarter of the wave, the node and antinode, that will be lambda by 4. Is it clear, this concept of a standing wave? So standing wave is the wave in which the particle vibrate, but they're not able to travel from one place to another, whereas progressive wave, the particle actually travels. These are some definitions which you have to learn. Then what is the difference between a wave pulse and a continuous wave? Wave pulse means when we send one wave or half wave or part of the wave, we call that as a pulse. But what is the meaning of continuous wave or wave train? So when we send wave and we are not able to identify what is the starting point, like there are 2 points, the wave is traveling between the 2 point A and B, but we are not able to identify the starting point and ending point. So what we call this wave, we call that as a continuous wave. So wave can be a pulse, wave can be a continuous. Pulse means like part of the wave, small part of the wave or full wave, that is called pulse. But when we send so many waves together and we are not able to recognize the starting or the ending position, so we call that as a continuous wave, or also known as the wave train. So this if x-axis is time, then it will be a time period. If x-axis is distance, then it will be a wavelength. So this was the start of unit 2, which is about waves and electricity. So we have discussed transverse and longitudinal waves and the progressive and standing wave. Any question related to the class today? Any question or a doubt?